Hello guys, welcome back to the channel. In this video I am going to discuss about Tischenko reaction. Yeah, the name is very funny. This is having a very strong analogy with Cannizzaro reaction. So let me start and tell you that how we are going to proceed. See, you have already seen in the Cannizzaro reaction that how in the presence of OH minus, two molecule of this reacts with each other and how the overall reaction used to be. One of the very important step in the Cannizzaro reaction is this hydride ion transfer, right? And that's how the whole process of the Cannizzaro reaction. So that involves the hydride ion transfer, H minus transfer, and thereafter acid base reaction will take place and it will become simply one part will become alcohol, other part will become. So that's why we say it is a disproportionate reaction, CH2OH and HCOO minus. One is getting oxidized, other is getting reduced. Now a very similar reaction is Tischenko reaction. So under that it is not necessary, the aldehyde in Cannizzaro should not have alpha hydrogen. But otherwise what will happen if alpha hydrogen is there, then a very great chances of having aldol condensation in the presence of OH minus. So because this will plug out this hydrogen and you are going to get that. Now if there is no alpha hydrogen, then Cannizzaro is possible. What about Tischenko? Tischenko reaction is possible even if you have alpha hydrogen with it, right? So I would like to quote with an example. Like suppose I took acetaldehyde, then you just need to take a Lewis acid catalyst, which is aluminum ethoxide, Al, OET, OET and OET, and in the presence of this simply heat this. So two such molecules are going to combine with each other and they are going to form an ester. Alright, they are going to form an ester. So how the mechanism will be, how it will look like, let's look into it. So the very first thing, whenever a Lewis acid is there, it will be seeking for a pair of electrons. So Al, OET, OET and OET, which is having a 6 electron altogether, it will be accepting the electron of aldehyde, and by doing that it will basically make the aldehyde more active for nucleophilic attack, because the moment it donates, it will acquire the oxygen of the carbonyl will acquire positive charge and aluminum will acquire negative charge. This bond is highly polar, right? But yes, the charge, and the moment it is getting a positive charge, it will increase more and more positive charge on the carbon, so which will attract even poor nucleophile also. Like in the mixture, now other aldehyde molecules which are there, they will react with this and this bond will move. So what we are going to get? So you will be getting simply CH3 OAl, यहाँ से आपके पास OET, OET और OET आ जाएगा. And what else will happen? तो आप देखो यहाँ पे हाइड्रोजन आ गया और यहाँ पे ऑक्सीजन डबल बॉन्ड O इसने डोनेट किया है, तो डबल बॉन्ड C and H and CH3. Now here it is very interesting. अब आप देखो यहाँ पे पॉजिटिव चार्ज जनरेट हो गया. द मोमेंट इट इज़ डोनेटिंग, हियर द कार्बन इज़ नाउ थ्राइविंग फॉर इलेक्ट्रॉन. सो व्हाट विल हैपन, अब आपके पास यहाँ पे ह्यूज बॉन्ड पोलैरिटी था, तो ये मेटल और एल्यूमिनियम, ऑक्सीजन, नॉन मेटल एंड एल्यूमिनियम बॉन्ड इज़ हाईली पोलर. सो यहाँ से ये शिफ्ट होगा, जैसे आपने देखा था कैनेजारो रिएक्शन में हाइड्राइड आयन यूज टू ट्रांसफ़र फ्रॉम वन कार्बोनिल सेंटर टू अदर. इन द सेम वे ये हाइड्रोजन आपका यहाँ पे आके अटैक करेगा और ये सिंपली नॉर्मल हो जाएगा. तो यानी यहाँ से अगर आप बनाना चाहो तो ये बन जाएगा डबल बॉन्ड O, एल्यूमिनियम आपका OET एंड OET, ये यहीं पे फिक्स, और उसके बाद क्या, यहाँ पे ऑक्सीजन एंड देन CH, ये हाइड्राइड जो ट्रांसफ़र हुआ था, और ये बन गया. तो ये क्या बन गया, एक एस्टर. कितना सिंपल है. दो एल्डिहाइड जिनके पास अल्फ़ा हाइड्रोजन भी है, वो भी अगर आप एल्यूमिनियम मिथॉक्साइड लेके हीट कर रहे हो तो आपको ये एस्टर का फॉर्मेशन करेंगे. यही रिएक्शन को टिश्चेंको बोलते हैं. अच्छा, इसमें अगर मैं बोलूँ तो क्या इसके अंदर भी डिस्प्रपोर्शनेशन हो रहा है, तो जी हाँ. आप देखिए इसमें जो कार्बन है डबल बॉन्ड O, ये कार्बन से एक और ऑक्सीजन ऐड हो गया, तो ये तो ऑक्सीडाइज हो गया. बट दूसरे मॉलिक्यूल का जो डबल बॉन्ड O था वो सिंगल बॉन्ड O में कन्वर्ट हो गया, तो ये कार्बन रिड्यूस हुआ. इसका मतलब कि द सेम कार्बन इज अंडरगोइंग ऑक्सीडेशन, is undergoing reduction. So such reaction is known as disproportionation. So this is also disproportionation. So Tischenko reaction, just like Cannizzaro reaction, is an example of disproportionation reaction.